Okay, good day everyone. So today our lesson is all about measures of central tendency of ungroup and group data. So we'll see if we can discuss or I can discuss the two, the ungroup and the group data. Let's start. So first we have the measures of central tendency. We have the mean, the median, and the mode. So first we will discuss the mean. Okay, what is the mean? The mean, also known as the arithmetic mean, is the most commonly used measure of central position. It is used to describe a set of data where the measures cluster or concentrate at a point. As the measures cluster around each other, a single value appears to represent distinctively the typical value. So the mean or the arithmetic mean means the average of a central position. It is the commonly known as the average. So how to get the mean? We have it is the sum of measures of x divided by the number n of measures in a variable. It's symbolized as bar x or x bar. So that is the mean. To find the mean of an ungrouped data, we have the formula. We have bar x, or the mean is equal to summation of x all over n. Where summation of x, so we have the summation of x, or the sum of the measures, and the number of values of x. So we have the example. The grades in geometry of 10 students are 87, 84, 85, 85, 86, 90, 79, 82, 78, 76. What is the average grade of the students? So let's solve the mean. So how to get the mean? Get the average. So we have this, the formula. Mean is equal to summation of x all over n. We have sum all the grades divided by the total number of grades. The total number of grades, we have 832. Then we have 10. 2, 4, 6, 8, 10. So 10 value. We have 10 values. We have 10, diba? 832 divided by 10. So the result is 83.2. So the average grade of 10 students is 83.2. So 83.2 is our mean. Next, the weighted mean. The weighted mean, there are some cases when values are given more importance than others. The mean derived in these cases is known as weighted arithmetic mean. The formula used in the computation of the weighted arithmetic mean. So we have weighted mean is equal to summation of x, or weighted x, the value of x, all over summation of w, or the weighted value. So where x represents each of the item values, while w represent the weight of each item value. So we have an example. Suppose we are interested in computing the weighted mean of the BS Ed Math 1 students in Wimsu Ipil, where he is enrolled in 6 subjects, having different units load as follows. We have 6 subjects. The first subject, we have 5 units. Second subject, 3 units. Third, we have 4. Next, 3 units and 1 unit. And lastly, we have 2 units. A total of 18 units. So, his grade, first subject, we have, he has a grade of 2.25, followed by 2.75. We have tres, the passing grade. And next, we have 1.25. Next, we have 2 and 2. Next, the weighted value of x. We have first subject, we have 11.25. So how to get 11.25? Just multiply the number of units to the grade. We have 2.25 times 5, we have 11.25. Then we have 2.75 times 3, 8.25, and so on. Then add. Add all the weighted values. We have 11.25 plus 8.25 plus 12 plus 3.75 plus 2 plus 4. We have the total weighted value of x. We have 41.25. Solve. The weighted arithmetic mean is equal to the weighted x all over the weighted value of, what is W? Let's go back. W is the weighted, represent the weight of each item value. So we have the units. So what is the total weighted value of x? We have 41.25 all over 18. What is our arithmetic weighted arithmetic mean? We have 41.25 divided by 18. So we have 2.29. That is our weighted arithmetic mean. Next, the median. Median is a middle number. So the median of a ranked list of n numbers is the middle number if n is odd. So if the value of n is odd, all you have to do is to get the middle number. What if the mean of two middle numbers if n is even? So if the values or the datas are even, so the two middle values get their average. So the average of two middle numbers, or the value of middle numbers, just get their average, and that is automatically the median. So example, the library logbook shows that 58, 60, 54, 35, and 97 books, respectively, were borrowed from Monday to Friday last week. Find the median. So since the data are arranged, are not arranged in increasingly or decreasingly, so all you have to do is to arrange first. So that's the first thing to do. Arrange the data. It's either increasing or decreasing. So in our solution, so arrange the data in increasing order. So we have 35, 54, 58, 60, and 97, since we only have 5 datas or 5 values. So we can see from the arranged numbers that the middle value is 58. So since the value or the datas are odd, so all you have to do is to get the middle value. Since the middle value is 58, so automatically 58 is our middle value or the median. Example 2. Andrea's scores in 10 quizzes during first quarter are 8, 7, 6, 10, 9, 5, 9, 6, 10, and 7. Find the median. Since we have 10 quizzes, so 10 means 10 is an even number. So all you have to do is to arrange the score in increasing order. You can also arrange the scores in decreasing order. It's up to you. Now we have 5, 6, 6, 7, 7, 8, 9, 9, 10, and 10. Since the number of measures is even, then the median is the average of two middle score. So with the formula, median is equal to, so the two middle score are 7 and 8. So add the two scores, then divide. So the same as how to get the mean. So we have 7 plus 8 divided by 2. 7 plus 8 is equal to 15. 15 divided by 2 is 7.5. So our median is 7.5. Next, we have the mode. The mode is the measures or value which occurs most frequently in a set of data. It is the value with the greatest frequency. To find the mode for a set of data, first, select the measure that appears most often in the set. So the data or the measures that appears most often or always appears in the set of data, that is automatically the mode. Next, if two or more measures appear the same number of times, then each of these values is a mode. So if we have two values that appears frequently, often in a set of data, so the two values is automatically the mode. Next, if every measure appears the same number of times, then the set of data has no mode. So if there is an equal number of data appears in the set, so automatically there is no mode in the set of data. Example, we have two value of 2, two value of 3, two value of 4, two value of 5, and so on. So the same number of data, the same number of times. Then in the given of data, in that example, there is no mode since it appears the same number of times. Okay, answer this problem. Find a mode in a given set of scores. Measures of central tendency of group data. Mean. So earlier I discussed that the mean is the average. So that is in ungroup data. Mean is the average, but in group data there is another formula. So the difference from the mean in group data and ungroup data, in group data automatically we can solve the mean easily, while in mean group data we can solve the mean easily, but there should be a table in it. So to get the mean, you should draw a table to find the value of mean. So to find the mean of group data using class marks, the following formula can be used. So you have mean is equal to summation of f of x all over summation of n, where f is the frequency of each class interval, x is the midpoint or class mark of class, n is the total number of frequencies or sample size. Example, the result of midterm exam of group of BS Ed Mathematics students in WIMSU APL are presented in a frequency distribution shown in table 3.1. Compute the value of the mean using group data. So we have the table. Class interval, you have 70 to 75. We have two data under 70 to 75. 76 to 81, you have 7 datas. Under 82 to 87, we have 20, and so on. Now, the total number of datas, we have 145. So we have f, the frequencies, x is a class mark, then get the f of x. Just multiply the two, f times the x. So how to get the x? So we have two ways on how to get the x. So we have since we have 70, 71, 72, 73, 74, 75, we have 6 numbers or 6 data. So just get 6 is an even number. So get the mean of the two middle numbers. So the mean of the two middle numbers, 72 in the first value, in the class interval we have 70 to 75. So In the first row, which is 70 to 75, the class mark is 72.5. So just if you want to make sure how to get 72.5, so just add 70 plus 71 plus 72 plus 73 plus 74 plus 75 divided by 6. So we have 72.5, or 70 plus 75 divided by 2, or 70, 71, 72, 73, 74, 75. So 73 plus 74 divided by 2, 72 plus 73 divided by 2 is equal to 72.5. So we have 3 ways on how to get the class mark. So, and so on. Then multiply f times x. We have 145, followed by 7 times 78.5. We have 549.5, and so on. Next, the total number of n. We have the total number of frequencies, which is the n. We have 145. The total summation of f of x, we have 14,082.50. Then solve. Compute the value of the mean using the formula. Round off the result to the nearest hundredths. So the formula, we have mean is equal to summation of f of x all over n. So we have the summation of f of x is 14,082.50. Then the total number of frequencies, we have 145. So our mean is 97.12 in group data. Next. Okay, answer this given problem. Next, a median of group data. The formula is a median is equal to the median of the lower boundary median plus the interval times the quantity of n over 2 minus the less cumulative frequency all over f, or the frequency of the middle class. So which our median of lower class boundary of the median class, I is the interval, less than CF means less than cumulative frequency before the median class, before. So n number of observation, or the total number of frequencies, fm of the frequency of the median class. So we have this. Find the median of the data in table 3.1 that test results of PhD and Math 1 students. So we have the same value. So our median, the lower class boundary is 93.5. How to get this? So first thing to do is to get the value of n. So our n is 145. The total number of frequencies. So 145 divided by 2 is 72.50. So less than cumulative frequency. So 72 point less than. So since our 72.5 is near to 89. So our less than cumulative frequency is 50. Yung mas maliit pa, or mas mababa pa sa 72. So 50. Then our lower class boundary is 93.5, since 50 is our 89 is our nearest, the less than cumulative frequency is nearest to 89, then the less than cumulative frequency just
subtract 0.5 to the lower class boundary, which is the 94. 94 minus 0.5 is equal to 93.5. So that's why we have 93.5 as our lower class boundary of the middle class, plus I, which is the interval. How to get the interval? Just count the numbers: 70, 71, 72, 73, 74, 75. So we have 6. 6. How to get 39? So 39. So just get the frequency of the middle class. So since 72 is nearest to 89, so 89 is our middle class. So 39 is the frequency, that's why we have 39. Then solve. 93.5 plus 6, so 72.5 minus 50 divided by 39 times 6, we have 3.46. Then our median is 96.96. Okay, solve this one. Okay, okay. May solution na pala. Okay, mode. Mode is the XLB, or the lower boundary of a model class, plus interval times model Fm sub 1, or the difference between the frequency of the model class and the frequency of the class interval preceding. So before it, all over Fm sub 1 plus Fm sub 2. So Fm sub 2 is the difference between the frequency of the model class and the frequency of the class interval following. So next to the model class, we have so compute the same value. So we have the highest frequency is 39, right? So 39. So we have the lower class boundary is 93.5, the same. The lower class boundary is 94. Since 39 is the highest frequency, then subtract 0.5 to the lowest class boundary, which is 94, minus 0.5 is equal to 93.5. Then Fm sub 1, 18. How to get 18? The difference, so we have 39 minus 21. So before, the difference between the middle class and the difference between the frequency of the model class and the frequency of the class interval preceding it. So 39 is our model class. So the frequency of the class interval preceding, which is 21, so the difference means subtract 39 minus 21 is equal to 18. That is our Fm sub 1. Our Fm sub 2 is 39, or the frequency of the model class, minus the frequency of the class interval following. So next, so 39 minus 27 is 12. So that is our Fm sub 2. Then follow the formula. 93.5 plus 6 times the quantity of 18, all over 18 plus 12. Then we have, so 18 divided by, so 18 plus 12, then 18 plus 12 is equal to 30. So 18 divided by 30 times 6 plus 93.5 is equal to 97.10. That is our mode in group data. Now solve the mode as we have the solution. Okay, thank you for listening. If you have questions, just PM me directly. Okay, that's all for today. Thank you.